Welcome back, guys. This is question 6.12 and 6.13, and as these two questions are closely relevant with each other, so therefore we are going to solve them in this video. So the statement of question 6.12 is the loaves of bread distributed to local stores by a certain bakery have an average length of 30 centimeters. So the average is given and standard deviation of 2 centimeters. Assuming that the lengths are normally distributed, what percentage of the loaves are A, longer than 31.7 centimeters, mean the probability that X is greater than 31.7 centimeters. B is between 29.3 and 33.5 centimeters, means the probability that X is greater than 29.3 centimeters and less than 33.5 centimeters and shorter than 25.5 centimeters, mean the probability that X is less than 25.5 centimeters. Okay, and it should be known here that the value of mean is 30, the value of sigma, which is the standard deviation, this is 2. Okay, these are in centimeter. All of these quantities are in centimeters. So what to do here, because these are the values of X, so first of all we have to convert them into Z, and then using the Z distribution table to find out the values, and then we will write them here. So let me first write the formula for Z. So for Z we know that Z is equal to X minus mu divided by sigma. Okay, so solving them here for each of one, for this 31.7 centimeters, we will have the value of Z is 31.7 minus 30 divided by 2. So this is 1.7 divided by 2. So 1.7 divided by 2 is 0.85. Okay, so therefore this is equivalent to what? Let me use this color for the Z. So probability that X is greater than 0.85. now the value has been transformed from small x to Z. Okay, but now we have difficulty in solving it, because in Z distribution table all the values given are in terms of the probability that X is less than some value. So therefore if you want to find out the value greater than it, we will have to find out the value that X is less than 0.85. okay, and we'll subtract it from 1. Okay, so let me solve it, and it would be what? It would be 1 minus probability that X is less than 0.85. so let me use the table 0.85. so this is 0.8, and the column for 5 is here, this one. So 0.85 is 0.8023. so 0.8023. okay, and subtracting it from 1, it would be 1 minus 0.8023. so this is 0.1977. so this would be 0.1977, and that is what? That is the solution for part A of my question. Okay, so this was for part A, and now moving towards part B. Here the values of X are these. We have to convert them to Z by using the same formula, and there we will get Z1, Z2. okay, by using the same formulation, which would be X1 minus mu divided by sigma, and X2 minus mu divided by sigma. Here the value of X Z1 would be 29.3 minus 30 divided by 2, and here it would be X2 is what? X2 is 33.5 minus 30 divided by 2. Here we will get 0.7. okay, minus 0.7 divided by 2. so this is minus 0.35. this is for Z1, and for Z2 we will have 3.5 divided by 2, so it would be 1.75. This is for Z2. So therefore this formula would become what? It would be, let me use this blue color. So it would be for the x, we will have x is greater than minus 0.35 and less than 1.75, and this would be the probability that x is less than 1.75 minus the probability that x is less than minus 0.35. You have to find these values and then write the answer of it. Let me write them here. So probability that x is less than 1.75, so this is here 1.75 is, this is the 1.7, this is the 1.7, and the fifth column is here. So 0.9599, 0.9599 minus probability that x is less than minus 0.35 minus 0.35, so minus 0.3 is here, this is minus 0.3, and this is the fifth one. Let me see, is it the fifth one? Yes. Okay, so 0.3631, 0.3631, subtracting it, let me subtract them. So 0.9599 minus 0.3631. okay, so here it is 0.5968, so 0.5968, and that is what, that is basically the solution of part B of my question. For this one, it is very easy. First of all, you have to convert it to Z as well. Okay, so let me convert this value to Z by using another color. Let me use this black color here. So the value for it is, Z is 25.5 minus mu is 30 divided by 2. So this is what? This is minus 4.5 divided by 2. So therefore the value of Z would be minus 2.25. here the value is what we know. So therefore this one has been transformed from 25.5 to the probability that x is less than minus 2.25. okay, so therefore now let us move to the table and find the value for the value of Z, which is minus 2.25. so minus 2.25 is, this is minus 2.2, and the 5 is here, so this is 0.0122, so 0.0122, and that is what, that is the solution of part C of my question 6.12. okay, so that is for the question 6.12. Now let us move to question 6.13, and what to do here, we will have to follow the similar steps what we have done for question 6.12. but what is the statement? A research scientist reports that mice will live an average of 40 months. So the average value is given when their diets are sharply restricted and then enriched with vitamins and proteins. Assuming that the lifetimes of such mice are normally distributed with a standard deviation of 6.3, sigma is also given. Find the probability that a given mouse will live more than 32 months, means the probability that x is greater than 32. Less than 28 months means the probability that x is less than 28, and between 37 and 49 means x is greater than 37, less than 49, and that is what, that is the probability. Now what would be the steps? Here again you have to convert it to the Z, this one to the Z as well, as here this is the first one, x is greater than 32. okay, so therefore the value for Z here would be x minus mu divided by sigma, the value of x is 32, the value of mu is what? That is 40 divided by sigma. The value of sigma is 6.3. Okay, you have to find it out and then you will write it here, and here writing it we would get what it would be. X is greater than some value which is z, and that value is minus 8 divided by 6.3. So 8 divided by 6.3, so that is 1.27. So here it is minus 1.27, so here it would be minus 1.27 as well. So in order to find it out, we will have to find the value for x less than minus 1.27, because the z distribution table is in terms of this one, and then putting this value, subtracting it from 1, we will get the answer, that is 0.8980. okay, so that is the solution of part A of my question, which is here. Less than 28 months means, let us move down somehow. This is part B, so we need to find out the probability that x is less than 28 months. So therefore, let me find the value for z here. So that would be x minus mu, which is 40, divided by 6.3. okay, so here it would be minus 12 divided by 6.3. so 12 divided by 6.3, here it is what? It is 1.90. so this is minus 1.90. so therefore here in transformed form it is x is less than minus 1.90, and finding the answer of it here, let me find here minus 1.9 and this is 1.90, so 0.0287 to 0.028 what 72, and that is the solution of part B of my question. Okay, in part C it will be the similar one as that of the part C of question 6.12, in which the value of x would be in between 37 and 49. okay, you need to find out the value for z1 and z2 for this value x1 and x2 by using the similar formula which is here. okay, this is a similar formula, and then what would you do? You will have to use the value which is x is less than z2 minus the probability that x is less than z1. okay, and by putting values here you will get the answer of part C, that is 0.6080. you need to give it a try and tell me if you understood the essence of these questions or not. So that's it for today, in which we have seen the solution of question 6.12 and 6.13. if you have any question you can ask me in the comment box. See you soon.